Hello, so in this video we're going to look at tangents and normals and we're going to really understand why differentiation is mainly used. So if you remember, differentiation is all to do with finding the gradient or the rate of change of something. So if I can describe a relationship as a curve, something like this for example, okay, so let's imagine that this is going through some x variable, and then on this axis we might have the y variable, okay? And then this curve kind of plots the relationship between the variables x and y through time. Then what I can do with gradients of tangents and gradients of normals is literally say, okay, how quickly am I changing at a particular point? So remember that a tangent is a line that just touches the curve in one point. It kind of lies like this, okay? So this is a tangent. Remember that tangent comes from the word tangential, which literally means to touch, okay? So it's how you touch something in one place. Now, if you remember that the normal basically lies perpendicular to the tangent, so this would be the normal, okay? It cuts through the curve. Okay, so that would be the tangent and that would be the normal. But the act of differentiating gives you the gradient function, and it's the gradient of the tangent function, okay? So if I have a look at this question here, so this question here, we've been given to, we've been asked to find the value of the gradient of the tangent to the curve y equals x squared minus 3x plus 2 at the point x equals 1. So if I take the curve y equals x squared minus 3x plus 2, and if I differentiate it, so just remember this is the same thing as we're doing in the last video, so I get 2x minus 3, okay? Then what this represents is a function. It's a function which will give me the gradient of the tangent at whatever point I'm interested in. So in other words, if I take this curve, which will look something like this, okay, then basically it says to me, this function down here, this function says to me, you tell me the point you're after, and I will tell you the value of the gradient of the tangent. Okay, so in this point we want at the point x equals 1, so we want the gradient at that point there, the gradient of the tangent at that point there. So all I need to do is just stick in x equals 1, into my dy by dx, my gradient function, and I should be given the value of the gradient at the point x equals 1. So let's have a look. We'll end up with 2 times 1 minus 3, so 2 minus 3, that gives me negative 1. So the value of the gradient of the tangent to the curve y equals x squared minus 3x plus 2 at the point x equals 1, just a simple case of differentiating it, that gives me my gradient of the tangent function, okay? Then stick in whatever point you're after, whatever it comes out is, that is the actual value of the gradient of the tangent. All right, fantastic. All right, so let's have a look at question 2, which is all to do with a similar kind of thing as question 1, but this time we're being asked to find the gradient of the normal, okay? So remember, the normal is perpendicular to the tangent, okay? So the way to tackle this question, if I get given the curve y equals 6x to the power 5 minus 2, okay? I'm again going to differentiate. I'm still going to find the gradient function. So dy by dx should be equal to, well, 30x to the power 4, and then the negative 2 will just become 0, okay? So this here is the gradient of the tangent function, okay? But that's okay, okay? I want the gradient of the normal, but it's still okay to find the gradient of the tangent because I know how the gradient of the tangent and the gradient of the normal are related to each other. They're negative reciprocals because they are perpendicular to each other. So let's find, first of all, the gradient of the tangent, okay? So let's find the tangent gradient. Well, the tangent gradient should just be a case of sticking in x equals negative 3 into my dy by dx function. So if I stick negative 3 in here, I get 30 times by negative 3 to the power 4. That should give me 2,430, okay? So that there is the gradient of the tangent. So if I want the gradient of the normal, because I know that if I have a curve, something like this, okay, here's the gradient of my tangent, okay, so that's my tangent. Well, my normal is always perpendicular to my tangent. And I know that if I have the gradient of one line, if I want to find the gradient of a perpendicular line, just think back to coordinate geometry, it's just the negative reciprocal, okay? So in this case, the normal gradient should just be the negative of my tangent gradient, so negative 2,430, but also reciprocated, so in other words, 1 over. So 1 over 2,430, and that's always going to be true, okay? So if you've been asked to find stuff to do with tangents and normals, okay, tangent is just using the ordinary derivative, okay? That's what the derivative function gives you. It's the gradient of the tangent. If you want to find normal gradients, then it's just negative reciprocal of your tangent gradient, okay? All right, so let's have a look at this question, question 3. Here we've been asked to find the equation of the tangent to the curve y equals x squared plus 5x minus 3 at the point x equals 1, okay? So because we want to find the equation now, just remember a tangent is just a straight line, which means I need two pieces of information in order to find the equation of that straight line. The first thing I need is a point which lies on the line, and the second thing I need is the gradient of that line, okay? So let's first of all try and find a point which lies on that line. Well look, I have the point x equals 1. Okay, I've been given that in the question. That's the point which I want to find the equation of the tangent at. So I know the tangent must pass through the point x equals 1, but I also need the y coordinate as well. Okay, so just remember this formula here, the y equals x squared plus 5x minus 3, that equation says you give me an x value, I find the corresponding y value as well. Okay, so in other words, if I want to find y, I just simply need to stick x equals 1 into this equation up here. So therefore I should get 1 squared plus 5 times 1 take away 3. That's going to give me 3. Okay, so y is equal to 3. So therefore I have an x and a y value. That's a point which lies on the line. Next, I need the gradient of this tangent. I need the gradient of the line. So therefore, in order to find the gradient of a tangent given a curve, I just need to differentiate. So first things first, I'm going to differentiate. I'm going to write down here actually. So I'm going to differentiate my function. So my y equals x squared plus 5x minus 3. Well, in that case, I get 2x plus 5. And I'm going to use the point x equals 1 to tell me that the gradient of my tangent is just going to be 7. Okay, so the gradient of my tangent is going to be 7 because I've just differentiated and stuck in x equals 1. Okay, perfect. Now I can use y equals mx plus c to actually find the equation of my tangent line. Okay, so let's first of all fill in what we've got. Okay, so I've got y is equal to 3, m is equal to 7, and x is equal to 1. I need to basically add c. So let's see, well, okay, what's c got to be? Well, in this case, c has got to be equal to -4, okay? So finally, the equation of my tangent line is just y equals 7x minus 4. That's the equation of the tangent to the curve y equals x squared plus 5x minus 3 at the point x equals 1. Okay, so let's talk through question 4 then. So question 4 says, find the equation of the normal to the curve y equals x to the power 4 minus 5x squared plus 7 at the point x equals 2. And we've been told to give your answer in the form ax plus by plus c, where a, b, and c are integers. Now, just remember that we are trying to find the equation of the normal. A normal is just a straight line. So therefore, I need two pieces of information in order to satisfy this. So I need to first of all find a point which lies on the line, then I need to find the gradient of that line. So let's find the point that lies on the line first. So I've got x equals -2. I want to find a corresponding y value. So let's think. If I use this formula up here, the y equals x to the power 4 minus 5x squared plus 7, and stick in x equals -2, then I should be able to find the y coordinate when x is equal to -2. So if I do that, if I stick in x equals -2 into my y coordinate, I find that my y coordinate is 3, okay? Now I need to find the gradient. Well, look, I can't find the gradient of my normal line directly. However, I know how to find the gradient of the tangent line. And I know how my tangent and normal lines are related to each other. So if I find the gradient of the tangent, I should be able to find the gradient of the normal relatively straightforwardly. So let's first of all differentiate to find the gradient of my tangent. So if I differentiate my x to the power 4 minus 5x squared plus 7, I should end up with 4x to the power 3 minus 10x, like so. And if I stick in the point x equals -2, I find that the gradient of my tangent line at the point x equals -2 should be given as, well, 4 times -2 cubed, that is -32 plus 20. Okay, so -32 plus 20, that's going to give me -12, okay? Which means that the gradient of my normal line should be the negative reciprocal. In other words, instead of it being -12, it should be positive 1/12. Okay, so there is the gradient of my normal line. Okay, so now I have a couple of points. Now I have a couple of ways to proceed with this. I have the two pieces of information I need. I have the point which lies on the normal line, and I have the gradient of the normal line. So I could, if I wanted to, use y equals mx plus c, just like in the last question. However, I'm going to use an alternative formula, an alternative form of a straight line. I'm going to use the form y minus y1 equals m times x minus x1. Now this just literally comes from the formula of gradient of a straight line. It's just change in y divided by change in x, and I just multiply both sides by a change in x, okay? The reason why I'm going to go for this one, couple of things, okay? First of all, the gradient is equal to a 12th. It's a fraction. Slightly easier to work with if you get given it in this form. The second reason why I'm going for this form is because I've been told to give my answer in general form. In other words, the ax plus by plus c equals 0, where a, b, and c are integers. Now I should put equals 0 there, okay? Where a, b, and c are integers, okay? So because I know I'm heading for general form, it just makes sense to make my life a little bit easier and just start with this. But if you're more comfortable with using y equals mx plus c, and that's the way you want to proceed, go for it. You'll still get the same answer. So let's fill in what we know. Well, okay, we have y minus our y1, which is our y coordinates, that's equal to 3, equals m, which is a 12th, times by x minus our x coordinate, which is negative 2. So I'm just going to do a quick bit of tidying here. First things first, I'm going to multiply both sides by 12. So I get 12y minus 36 is equal to 1 times by, well, okay, 1 times by x minus minus 2, that's going to be x plus 2, okay? So x plus 2 on the right-hand side, okay? So now all I need to do is just rewrite this so I get given it with everything equal to 0 and they're all integers. So if I add x to both sides, sorry, if I take away x from both sides, I end up with negative x plus 12y, and then again, if I take away 2 from both sides, I get negative 38 equals 0. So you see how quick and easy it is to get given it in general form if I use this y minus y1 equals m times x minus x1. But you still would have got there, by the way, using y equals mx plus c, just would have been a bit more of a hassle with rearranging.